students, welcome to chemistry classes. Under this hydrocarbons, today we are going to discuss another one type of isomerism called geometrical isomerism. Geometrical isomerism under the category of stereoisomerism. What is geometrical isomerism? These olefinic compounds having the same molecular formula but different spatial arrangement. The compounds having different spatial arrangements leads to differ in their properties, either physical or chemical or both physical and chemical properties. Such type of isomers are called geometrical isomers. The phenomenon is known as geometrical isomerism. Now, what are the conditions for this geometrical isomerism? The first and important condition for arising geometrical isomerism is the olefinic compounds must having a double bonds. Compounds must having a double bond. Olefinic double bond must be present. The second one is different atoms or groups attached to the same carbon atom. Here X, Y, Y. Different atoms or groups attached to the same carbon atoms. Suppose it may be written like this: X, Y, Y means same atoms attached to the same carbon atom. There will be no geometrical isomerism possible in this case. So, different atoms or groups attached to the same carbon atoms, the basic and necessary condition. And also restricted rotation about carbon-carbon double bond. Restricted rotation about carbon-carbon double bond. Now, let us consider, you imagine these two papers are as a two cardboards or a wood. Now, I join these two cardboards with the help of one iron nail. Now, these two papers look like this. So, the green pencil here refers to one single bond. Therefore, pre-rotation is possible. Pre-rotation, the elements or atoms attached to the carbon-carbon single bond, pre-rotation is possible. Now, again another one iron nail joined the two cardboards. So, now it became like this. So, listen, now these compounds are attached with two olefinic bonds or carbon-carbon double bonds. Now, restricted rotation, there will be no mobilization of carbon-carbon double bond. This is the basic condition for geometrical isomerism. Restricted rotation about carbon-carbon double bond. But now this spatial arrangement may vary. Listen, this olefinic bond X and X, Y and Y. So, there are some changes in this spatial arrangement. Geometrical isomers are classified into two types. First one is cis isomer and the second one is trans isomer. Cis isomer and trans isomer. What is cis isomer? Same atoms or groups attached to the same side of the olefinic bond are called cis isomer. Same atoms or groups attached to the same side of the olefinic bond is called cis isomers. The same atoms or groups attached to diagonally opposite to the olefinic carbon-carbon double bond is called trans isomer. Cis isomer means same groups attached to the same side. Olefinic bonds, that is the diagonally opposite side. Similar groups are attached to diagonally opposite to the olefinic carbon-carbon double bond are called trans isomerism. Now, we consider one general example, that is 2-butene. 2-butene. We know the structural formula for 2-butene, CH3. How to draw the cis and trans isomers of 2-butene? This is one of the important questions in the examination point of view. So, first you choose the olefinic bond, that is C double bond C. In the second carbon, one hydrogen is attached and another one methyl group. Third carbon, hydrogen and methyl group. Now, similar groups are attached to the same side. Therefore, it is called cis-2-butene. Cis-2-butene. Now, exchanging the groups HH, CH3, CH3. That is trans-2-butene. Trans-2-butene. Cis-trans isomers of 2-butene. The cis isomer and the trans isomers are differ in their physical properties. The compounds are differentiate by their physical properties. These compounds differ by physical properties, especially melting point, boiling point, refractive index, solubility, crystallization. These are the some of the points which are majorly differs by both cis and trans isomers. Dipole moment is the one of the characteristic property which is used to distinguish both the cis isomer and the trans isomer. Cis isomer and the trans isomer. The cis isomer is polar in nature. This compound mostly polar in nature. This compound mostly non-polar in nature. Cis isomer polar in nature. The trans isomer is not polar in nature. And also these compounds, the cis isomer and the trans isomer, the similar bulky groups are present in the same side. Therefore, it has experienced certain van der Waals force of repulsion or steric interaction. So, bulky groups are present in the same side. This may lead to instability of the molecule. Cis isomer is less stable when comparing to the trans isomer, or trans isomer is more stable than the cis isomer. Why? What is the reason for this? This is similar groups are present in the same side due to the van der Waals force of repulsion or steric effect or hydrogen bonding leads to the less stability of the cis isomer. And it shows certain dipole moment value. Dipole moment value is suppose 0.33 d by units. It has some value, but here the dipole moment values are dpm values are 0. Dipole moment values are 0. So the two compounds are differed by this dipole moment value. One compound is easily converted into another isomer. Cis isomer is converted to trans isomer by heating. Heating in a certain temperature, cis isomer is converted into trans isomer. How we convert cis isomer to trans isomer and vice versa? While heating, the breaking and making of pi bond takes place. Here one pi bond and another one is the sigma bond. Pi bond is a weak bond. We know that the pi bond is a weak bond. Once the pi bond break, at a time the exchange may occur. So, breaking and making of pi bonds in olefinic carbon atoms present in the geometrical isomers, one isomers can easily converted to another isomer. One isomer can easily converted to another isomer. So, these are the some points about this geometrical isomerism. Now, we are going to discuss certain problem part for this geometrical isomerism. You turn your textbook page number 379, problem 13.10. Problem 13.10, draw the cis and trans isomer for the following compounds. The first question is like this. CHCl double bond CHCl. How to draw the cis and trans isomers? First you draw the olefinic bond. And what are the atoms present here? Here on hydrogen, here on chlorine, HCl. Here hydrogen and chlorine. So, both chlorine atoms are present in the same side, cis. What is the name of the compound? 1,2 dichloro. ethene, 1,2-dichloroethene. And similar way, trans, Cl, Cl, H, H. This is trans 1,2-dichloroethene, 1,2-dichloroethene. And the second compound is like this, C2H5, C, CH3 double bond, C, CH3, C2H5. Here also the double bond, olefinic double bond. First you choose the olefinic double bond, and first part, one part CH3, another one part C2H5. CH3, C2H5. So this is the cis isomer and the trans isomer. CH3, C2H5, CH3, C2H5, CH3. This is trans isomer, cis isomer and trans isomer. Similarly, problem number 13.9, predict whether the compounds having cis isomer or trans isomer. The first compound is CH3 twice C double bond CH C2H5. So again you draw this olefinic bond. Here two CH3 groups, CH3, CH3. Here H C2H5. Whether this compound is having geometrical isomerism? No. What's the reason for this? Same groups attached to the same carbon atom. If same group attached to the same carbon atom means there will be no geometrical isomerism possible. So what is the way to write the geometrical isomerism for the same compound? If it is written like this, HCH3, HCH3 or CH3 C2H5, HC2H5, HC2H5, CH3 CH3. Now it is a trans isomer. Again you can draw the cis isomer also. So another one compound CH2 double bond CBr2. Here also C double bond H H Br Br. Same atoms or groups attached to the same carbon atom, there will be no geometrical isomerism possible. But if it is in this form means H H Br Br means it shows the geometrical isomerism. You can go through the next part, third and fourth also. If you have any doubts, you may ask. Thank you.